Alright guys, we're going to pick up on this big F equals MA project where we left off. This is page 4, and it's the chart that you should have already filled in all the way up to position 10. So the time, you just copy down, or you can just add 0.087 every time. Distance, we had to figure that out from this image over here, right? And you noticed I've zoomed in a little bit. I've found that it's helpful to zoom because that way when I want to write something or draw something, it's way easier to set it exactly where I want it to go. So I can zoom in and zoom out easily and quickly up here. So I recommend you do that too for writing stuff. It's way easier to do it if you've zoomed in and get it in the right place. Okay, so the next thing, after you've filled in the chart, there are some questions for you to answer. Number one, it's not really a question, it's more of a statement. And then there's some questions about it. Please make sure that you do this where it says justify your answer, okay? So when it asks you to justify something, that means to explain why you gave your answer. What evidence do you have to support that idea? Okay? So make sure you're justifying or explaining why you gave a certain answer. When you're done with that, we get over here to a graph. So here's the big set of instructions. So you're going to use data from the data table, which I was calling a chart a moment ago. Use that data to complete the graphs. Remember to look for patterns. So the first pattern I want to show you is the pattern in the graphs themselves. The first graph that we have has a title of time versus distance. It's a comparison of the amount of time that has gone by versus the distance that the ball has fallen. Notice time is on the bottom and distance is on the side. Oh, how handy. They've already made this graph for you, haven't they? So for this graph, all you have to do is answer a question and justify your answer. Okay? So let's go back and see where they got that data. Basically, they were comparing time and distance. I'm going to undo that. First graph that they made for you, we were comparing time to distance. Second graph, what I want you to notice here is they gave you a title, and they put titles on each axis, but now you have to make your own graph. They've told you what data to graph now. Time versus velocity. So you're going to go back here. You're going to compare time to velocity for the second graph. And guess what you think you might do for the third graph? That's right, you're going to compare time to acceleration. 3 graphs, all of them have time on the x-axis. So that's one pattern I've found. Time on the x-axis here for the one that they made. Time on the x-axis for this one that you're going to make. This one's not labeled, but guess what this is going to be? Yeah, that's also going to be time down here. And let me see. Come on, let me write. Thank you. So down here, we're going to have time. And what's going to be on the side? Well, it tells you in the title what's going to be on the side. So over here, it's going to be acceleration. Please include a title on each axis every time we make a graph all year long. I want to see a title at the top, and I want to see a title on the y-axis, and I want to see a title on the x-axis. Okay? So what I would recommend for you when it comes time to make these graphs for yourself, take a picture of your data so that you don't have to be scrolling back and forth. If you take a picture on your phone, just look at the data on your phone. Okay? So, let me see. I wonder if I can erase this. I want you to remember that the first graph was time versus distance. That one, they've already done for you. So I can scratch that one out. It's already done. The second one is time versus velocity, so we need to do this one. So what I'm going to do, 0, 0 is where I'm going to start. And I have to put a point at 0, 0. And there's some options. I could use the pencil tool and draw a point. Right? It might not come out very good, though. So, what other options do I have? Well, I found that if I go to fill in sign, actually a student showed me this, it was pretty handy, it was cool. I go to fill in sign, come on, takes a minute sometimes to change the commands. And up here, this allows me to make a dot. See how it says add dot right there? This changes the color. I'm going to go with black. Classic, right? So let's go back here, and I believe I needed to put a dot at 0, 0, right? So there's my first dot. Again, if I zoom in, it's going to be a little easier to find these things. Now, what's my second one? Again, take a photo so you don't have to jump back and forth. I have 0.087 versus 0.92. Remember, this is the second graph, time versus velocity. Whatever's over here for time, I have to graph that against the velocity in the same row. So let's go down, time versus velocity, 0.087, 0.92. I got to remember that. I'm going to go over here, and I'm going to write it so I remember. Then I'll delete this later. See how I got this set of commands out of the way too? This little arrow will hide those and it zooms in for me. So I have to find 0.087 on the x-axis. Is that 0.8 right there? Is that what? Oh, it's 0.087. That's got to be less than 0.1, doesn't it? Maybe we should talk about what these little lines are along here. So I'm going to zoom in even more so we can take a closer look at this. So if this is 0.1 and it has 5 boxes, this is like 0.10, isn't it? Or like 10 cents? And if you took 10 cents and divided it by 5 boxes, wouldn't you get 2 cents for each box? So basically, this one, I'm just going to write, I think, right here would be, can I make this a smaller? Yeah, see how I can change this too? I go to the properties, I'm going to change how thick it is. That's a little thick for me to be writing with. So that's a thinner line. This one is actually going to be 0.02. And that was a fail because I wanted the thinner lines. So I'm going to do this, go back to properties, make it be 1, and I'm going to make those properties the default. I'm going to keep it at that. So this is 0.02. This one, 0.02, 0.02. This one, we're going to count by 2's, 0.04. You do not have to fill this in like I am. I'm just showing you what these numbers are so you can figure out where to graph things. 0.06. And this one would be 0.08. Now think of this like money. 2 cents, 4 cents, 6 cents, 8 cents. That would be 10 cents right there, huh? Because isn't it basically 0.10 is the same as 0.1, right? And so you're counting by twos. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All right? So, what was my number? 0.087 and 0.92. 0.087. Well, that's almost 0.09, which would be at the halfway mark, and that's about as good as we can get, isn't it? And then we had 0.92. Once again, I want to use the dot. And 0.087 right there. 0.92 is so close to 1, it might as well be right there. I wonder what happens here. I don't know. I thought maybe I could change the size of that. Oh, this changes whether it's a check mark or a line or a circle, an X. But what I want is a dot for the graph. Okay? What's my next number? I have to go back here. Like I said, take a phone. You won't have to jump back and forth. Remember, it's time versus velocity. 0.174 versus 1.72. 0.174 versus 1.72. Let me write that down again. Come on. 0.174 and 1.72. So the time was 0.174 seconds. The velocity was 1.72 meters per second. So where's 0.174? Well, remember, these are counting by twos. Every little mark is two more. So there's 0.1, 0.12, 0.14, 0.16, 0.18. Oh, so 1.174 must be right about here, almost to the 18. 1.72 is almost to the 2, right about where my marker is there. But I want to put a dot in there, so I'm going to go back here. 12, 14, 16, 1.72, like right there. There's my third point. What is my fourth one? 0.261 versus, don't get confused, we're not doing distance. We are doing velocity, right? So for this graph, only look at these numbers in these columns. Ignore everything else. 0.261 and 2.53. I'm going to write that down again so I don't forget. 0.261. Hello. Where are you going to let me write this time? There we go. 0.261. What? 2.63, is that right? I better double check. 0.261. 2.53. Okay. Good thing I checked. So that should be 53. Right? So I need a dot. I get the dot over here. 0.2. 22, 24, 26.261, right there, 26, and 2.5, 2.53, 1, 2.5. So you're going to do 10 of these points, while I only, of course, do 4 of them for you. Then you're going to connect them with a line, or a series of lines if you like. I find this pretty nice to make a line right there. So, whoops. What's going on? Okay, there we go. So I can grab that, and I can also adjust it. See how I can change where that line is? I can adjust it here. Well, that's pretty good. I might as well just make that one big line. What do you think? All right. And I can see the trend. Is it okay if some of the dots are not quite perfectly on the line? I think so. If they're slightly above or below, that's okay. We call that a best fit line. Because there's going to be some little measurement errors and some little mistakes in calculations, but overall you should see a trend, something like this going on. So that's how you're going to do this graph. Let's zoom out a little. After you finish this graph, of course you're going to answer some questions, and of course you're going to justify your answer. Then you're going to go down here and you're going to see, oh, I need to make another graph. This one is time versus acceleration. Go back to the photo you took of the data table so you don't have to scroll like I am right now. Let's see, we just finished the velocity one. Now we have to do acceleration. So once again, we're going to stick with these same numbers for time across the bottom, but now we're going to graph acceleration. 0, 0, 0.87 versus 10.58. So once again, we're going to come down here, and I'm going to make a dot. You don't have to make a dot, though. Here's another option. If you can't find that, you could make an oval. So what I would do is just go someplace where you have some space to work and try to make a pretty small circle. What does that look like? Yeah, that's not bad. Now, I activate it like that. If it was bigger, or I could make it bigger if I wanted to, right? See how these things come around? This is when it's activated. If I click somewhere else, it's no longer activated. And I can drag it, well, I'm dragging the whole paper. To drag it somewhere, I have to activate it. Got to click on it. Then I should be able to move it where I want. Ah, there we go. You see how the hand turns into a cross? That's when you can move it where you want, when it turns into a cross. You can also grab these things to change the size. I want a small circle. When it's activated, I can also copy and paste it. Now I'm going to have to make 10 circles on here, and the likelihood that I'm going to draw every one the same exact size is not very good. It's going to be hard to make them all the same. So that's why I am, instead of drawing it 10 times, I'm going to activate it, then I'm going to copy it, and I'm going to paste it 10 times. See how I'm getting that circle over there? It's showing up for me. Multiple circles. I'm not going to do it all 10 times, but you get the idea. Now the first one, I believe, I have to activate it, remember. And if I move it now, it's going to stretch it out. I don't want to do that. Here's a good trick for you. Control Z or Command Z will undo whatever you just did. You can also do Edit and Undo. You can also redo something that you did. So I want to try to grab this. That's going to stretch it out. That's no good. That's going to stretch it out in both directions, isn't it? Okay, I don't want to do that. So what I'm looking for, oh look, it looks like an arrowhead. What does that do? Oh, perfect. It allows me to drag it. So I drag it to the 0, 0 spot. What was my next number? 087, 1058. 087, 1058. So my second one, it's an arrowhead ready to go. Remember, this is 08. A little more than that is 087. And I need to go all the way up to 10.5. 10.58. There's my next one. If I click somewhere else, it'll just stay there. Go back. What's my next one? 174, 986. 174 and 986. 170, 112, 14, 16, 1874 is right in between. And that was 9.86, just less than 10, right about there. What's the next one? 261, 9.7. 261, 22, 24, 26, 9.7. All right, you see how I'm doing that? So you're going to keep going. Now what I'm seeing, when it comes to drawing the line, there's like this going on, right? And then there's kind of something along here going on. It's hard to tell what this is going to do in the future, but I might have to have two different kinds of lines happening, huh? This is a pretty straight line, actually, right? So that's how you do this next graph. Let's see. Oh, what's next? Answering questions, justifying your answers, and then you're going to give your opinion about which way to report data you think is easiest to understand and easiest to see patterns. Is it the raw data that we started with over here, which I've erased? Is it the data table, the chart? Does that help you see patterns better? Or is it the graphs? Do those help you see patterns better? What do you think? What's your preference? That takes care of page 6. When we get to page 7, we got to read the instructions. Better zoom out a little. Let's go back to the data table. Add another heading that says force. Okay, I'm going to do that. I need to write. I need to add force over here. Now, do you guys remember the equation for force? Why don't we write that down right now? F equals, you better remember that equation by now, boy. F equals ma. Force equals mass times acceleration. Okay, so what do we have here? Position, time, distance, velocity. Oh, there's acceleration for me. I need mass, don't I? To find the force of the falling ball, I need the mass. It's not here. Let's go back, look at the instructions. Add another heading to the data table. Force equals just force. The falling ball has a mass. Oh, look at that. It gave us the mass. It's 0.1 kilograms. Calculate the force on the ball as it falls. Complete your calculations. And then guess what you're going to do? Yep, you're going to make a graph. Now be careful. Down here, they didn't put a title. And what do you think it's going to be? If you noticed anything, it's going to be the same pattern over and over again. We have just calculated force, so that's going to go here. But what they didn't do was give you an overall title. So you need to put your own title up here. I will be looking for that, okay? Let's go calculate some forces. I know, I'm forcing you to do this stuff, huh? F equals ma. I'm just going to make a note to myself. The mass equals 0.1, right? All I have to do is multiply mass times acceleration. Multiply this times whatever was in this column. Well, this is an easy one. 0 times anything is, of course, 0. Makes sense. There's no force before it starts to fall. 10.58 times 0.1 equals 1.058. I'm going to round that off to 1.06. The 8 is a little bigger than 5, so I make this 1.06. 1.06. Next one. Mass, 0.1, times 9.86. Clear everything. 0.1 times 9.86 equals 0.986. I see that this last number is bigger than 5, so I add 1 to the 8. I get 0.99. By the way, force is a very interesting unit. Like distance, we measure in meters. Time, we measure in seconds. Velocity is meters per second. Acceleration is meters per second per second. And notice that's part of force that we're going to multiply by mass. So it is kilogram meters per second, which is a messy type of a unit. So they just renamed this unit of measurement after Isaac Newton. So we say that this is a force of 0 newtons, a force of 1.06 newtons, 0.99 newtons. Last one I'm going to do for you, 9.7 times 0.1. Always times 0.1 for this column. It's pretty simple. Times 9.7. I don't need to put the 0 in if it's at the end, right? And I get 0.97 is my answer. 0.97 newtons. The abbreviation for that is N, or even better if you put it up here. Right? Okay, so that's how you find force. Then you're going to do the same thing with graphing. It's going to be time versus force. So now we have to put time and force on this next graph. 0, 0, again, 0.087, 1.06, like that. Except I think there was something weird about that graph. Let's look at what they say. Okay. Label the x-axis. Oh, I made a mistake. Guess what? This isn't time. Okay. I just made that assumption it was time. It's not time. It tells me that it wants mass down here instead. Mass. Measured in kilograms. M is the abbreviation for mass. Here's the N for newtons of force. I already did that. Plot the mass versus force data. It should just be a single point. Oh, I get it. Because the ball always had the same mass. The ball was always 0.1 kilograms, right? So really the best thing to do for this one, after you get all 10 of these, find the average force. How do you do that? You add them all up. Let's skip the 0 because that will throw off our data. Skip the 0. Add these up and divide by 10. But I'll give you a hint. Aren't these all pretty close to 1? Imagine if this was money. That would be $1.06. That would be 99 cents. That would be 97 cents. Don't you basically have $1? Don't you basically have a force of 1 Newton, more or less? Right? Something close to that. So, if I go back here, I'm only going to put 1 point on here. Look at that. It says it should just be a single point. Because the mass is always the same. The ball always had the same mass. So the ball was 0.1. The force was 1. Where am I going to graph that? Well, 0, 0.2, 0.4, 0.6, 0.8, 1.0. Okay, but it's 0.1. So that's going to be over here, halfway between 0 and 0.2. And as I recall, the I'm going to get a dot ready to go. As I recall, it was 1 Newton. So just 1 dot right there, and you're done with number 9. But on number 10, they want you to take this data and add it to the table. Here's the mass across the bottom. Here's the force up the side. For example, let's do this one. 2.6, 2.2, 0.4, 0.6. 2.6 was 25.5. Oh, I went too far. 25.5 is about there. Okay? Mass versus force. So you're going to plot those 4 points. Now, what are you going to do? Calculate the acceleration. To do that, we're going to take our equation of F equals ma and we're going to turn it around. This is algebra, you guys. I hope you've done some algebra before. We want to get acceleration by itself. To do that, we have to divide by m on both sides of the equal sign, which means acceleration is force divided by mass. So what's the first one? 2 divided by 0.2. Let's clear all this away. 2 divided by 0.2 equals 10. I need to be able to write again. I want to get rid of this. There's my writing thing. What did we say it was? It was 10, wasn't it? Sometimes it takes a minute for this thing to wake up when you switch from one set of commands to another. Yeah. There we go. So that was 10. Then we have 1 and 9.8. Divide, right? Force divided by mass. 9.8 divided by 1. 25.5 divided by 2.6. Okay? So you're going to fill that table in. There are some questions for you to answer. Oh, check it out. You have a bonus for extra credit. But it looks to me like E is not a bonus. They want you to predict the force when the mass is 5 kilograms. How would you make a prediction? Well, what I would do if I was you is I would look at the trend line that you drew earlier. So if we have a line going like this, and I want to predict what it is when we get to 5, what should I do? Well, would I draw another line straight across to 5? Would that make sense? Probably not. It might make more sense if I'm not sure how I did that, but anyway, it might make more sense if I continue this same line in the same trend, right? So it's a straight line, and my prediction is where my new line hits 5. That would be my prediction over here. If I have a mass of 5, and I go up to the trend line, then I can take it back to see how much force there was. And that'll be my prediction. And that finishes the whole thing, except this last page. You can do that for extra credit. It's a little puzzle. So I challenge you to do that. It is not required, all right? Please send me a note if you get stuck on anything and we can talk. All right, thanks for joining me. Bye.